Okay. Last class, we talked about the product rule, quotient rule, chain rule, okay? Yeah. And we use all of those rules to derive those important formulas. For example, we use the definition of derivative to get a sine x derivative. Sine x derivative, by this definition, you don't need to say, oh, this is too complicated, it's hard for me to understand. You just think about it, it's a function. It's a function. You are looking for 2 points on the curve. You are looking for 2 points on the curve. And this formula is just a delta y divided by delta x, which is basically the slope. So when your h is approached to 0, very, very small, then this small line segment slope is going to be equals to this tangent line slope. In this way, you can calculate the instantaneous slope, which is the derivative. So sine x derivative will be sine of x plus h, which is a second point value, y value, minus sine x, and then divided by h. Well, you see, I don't remember this formula. Then you go back to your pre-calc. I don't have time in this class to help you go through all those formulas, okay? You minus this, and then you can extract sine x, and you do cosine h minus 1. H approaches 0. Cosine 0 is 1. 1 minus 1. So this guy can be ignored because you can draw this graph here. You know this, when h approaches 0, this is going to be 0. And then we can do here. This one, when h approaches to 0, sine h and h is the same level. This is the same level. The thing you are going to learn later in calculus BC is the Taylor series and the Maclaurin series. Actually, if you draw a sine x over here, and then you can use x plus x to the power of 3, and then divided by 3 times 2, which is 3 factorial. And then you do one more, plus x to the power of 5, and then you divide it by 5 factorial. Okay, you keep doing this, and then this part is going to be simulate and very close to this. If I hide other parts, you think these two are exactly the same. But when I show you, oh, you can tell they are not exactly the same. So you can use those series to approach the trigonometry values, which we will not learn in AB. We will only learn this part until calculus BC. Based on the definition of here, we get sine x derivative. And then we can go ahead use some trigonometry identities to figure out the cosine x derivative. Now I'm going to check if students remember how we derive those formulas. Everybody, you have a chance to be asked several times in each class. Hey, Christina, how do we get this one derivative?
You change it into sine pi over 2 minus x of derivative, and then you use the trig identity.
So this is just the cofunction, okay? This
Right.
guy, this is cofunction, so these are identical. And then you are going to use this formula to figure out the next step. Go ahead, please.
It's cosine pi over 2 minus x.
Sine derivative is cosine, so you
Right.
Write down this, copy down whatever inside. And then this guy inside.
It becomes -1.
-1. Again, this one who should equals to who?
Sin x.
So this value give you a negative
Negative
sign
sign.
x. So far, so good?
Yeah.
Okay, so this is called the chain rule. You don't have a direct function. You have one inside another. To do this composite function derivative, if you treat this inside and not touched, just copy down. But you do this out layer derivative. And then you will treat this as another inner layer you do over here. So you might wonder, I don't understand why this is true. So I'm going to show you why you can do this way. You can see y equals to a phi f of x, and u is a g of x. Okay. Next, you put y out layer. You put a g inner layer. So who is gx? U is gx. So you will copy down u over here. Now, this whole thing, you want to do dy over dx. You know that y equals to this guy total. So this whole thing is y. And your inner independent variable is x. So your dy over dx. Dy over dx is going to equivalent as dy over du times du over dx. The du parts can be canceled to each other. So dy over du is who? Dy over du is this guy. This is dy over du. Who is du over dx? Then it's an inner one, which is g prime of x. That's why this chain rule is true. You say, can I do 3 layers? Yes, you will be able to do many, many layers to apply the chain rule. As a matter of fact, for Clemens, they always give you like 6 layers and students get frustrated, okay? Next rule is the product rule. Right, I want you to fill in the blank over here. How do we manipulate with this product rule? Go ahead, please. Go ahead, Ryan. What I should write down here? Ryan, you can unmute yourself. I'm waiting for you to answer questions. I cannot hear you, Ryan.
Can you hear me?
Yes, I can hear now. Go ahead.
Right.
What you can do here?
So you would do f of x plus h times gx plus h minus f of x times times gx plus h plus f of x times gx plus h minus f of x times g of x, and then over h.
Okay, that's very good, which you manipulate with these middle parts. And as a matter of fact, you can tell this guy is a common factor and you extract over here so that you have this piece, right?
Mm-hmm.
And then again, fx as a common factor can be taken out to put here, and then you have this guy. So far, so good.
Yeah.
And by the definition of derivative, this is that guy. By the definition of this guy, exactly g prime x. And then you say, hey, this is not the same. You should put plus h. Remember, we are doing limits. So when h approach to 0, that's this guy. Okay, So this is the product rule. This is the product rule. Next, quickly review for the power rule. Power rule is easy. Pull the n in front, put x to the power n minus 1 on the shoulder. Okay. Next one is a quotient rule. I need to ask students to show me that you can do this guy. Let me call the student. Lily, let's give a try here. Let's try here. When we talk about the product rule, because this is in the quotient rule, suppose we forget the quotient rule. How do we derive this? We can treat this divided by this as this times this, right? Yes. And then the product rule we mentioned just now, this guy derivative, and then copy down that guy, and then plus who? Can you give a try? You can apply the power rule, right? And the chain rule. Look at this. This guy derivative, you can pull the negative one in front. Can you? Can you do this? You do negative 1. The out layer is a power rule. So you put negative 1, and then you write gx to the power of negative 1 minus 1, which is negative 2, correct?
Yes.
Okay, and then you will do the inner layer, which is gx derivative, right? You got it? You got it,
yes.
Lily? Yeah. Did you have a chance to take a look at the video because you missed the last class?
I didn't get to finish it yet.
Okay. Now, look at this. Are you okay for here?
Yes.
Next. Now you go through with me together, okay? Next, can we put this guy in the denominator? This will become who? What you can write down here?
G of x to the g of x squared.
So you will put gx squared in the denominator. And then on the top, it's going to be how much?
-1 times
G prime 1x, right there. Yes? So far, so good. This is guy you copy down here, and this is guy you put here, and you minus, you write down this. So far, so good.
yes.
And then this guy and this guy, you want to do the same denominator, so you change to this guy square. So far, so good.
Yes.
And then you do f prime times g, and then minus fx times g prime. You put the same common denominator. So here is f prime x times gx, and then minus f prime x times g prime x. Oh, I missed one term. I need to copy down the fx here. Okay, in that way, everything will match. So far, so good now. So now we want to remember the quotient rule. Quotient rule is really important. When you do the quotient rule, you make this appear as a square. And then you treat the top one derivative, copy the bottom one, minus the top one copy down, times the denominator's derivative, okay? After trying this several times, everybody will remember. Next, let's do tangent x derivative. I suppose everybody can do it now. Tangent x derivative, Judy, let's try it together.
Well, you can do oh
Don't look at your notes, just look at the screen.
okay.
Yeah. So you will
So,
put, look at this. We have this rule right here. We
oh
have
yeah,
this
yeah,
rule right here.
sorry. So it's going to be sine x. I mean, yeah, cosine x times sine x prime, which would be
So hold on.
cosine.
The top one derivative, copy down the bottom one, and then
Yeah.
minus the top one, copy down,
The
and then
derivative.
the
Yeah. And then all over cosine x squared.
look here. I need to
I mean,
talk
squared
about
x.
this. Look the sine square x is same as do the sine first, do the square second. But if you write down this is saying you do the x square first, and then you do the
Yeah.
sine. These two are totally different. Don't
Yeah.
mess up here.
Uh-huh.
And their graphing is totally different. Look at this. This is sine x squared. You may wonder why this looks like a negative cosine. It's because of the double angle formula. This will be 1 minus cosine 2x totally divided by 2. That's why this is showing a graph as a negative cosine x shape. And if you do sine parenthesis x squared, these are totally different. Okay, we don't mess up between these two. Keep going.
And so the derivative of sine x is cosine x. So it's going to be cosine x squared.
And we see
And then-
cosine square x.
I mean squared x, sorry. And then the derivative of cosine x is negative sine x. So it's going to be plus sine squared x.
Okay.
All over cosine squared x.
Mhm.
And so you can split it up as
The top one is who? What are those special
oh
trig
yeah, I meant
identities?
like what, so it's going to be 1 over cosine squared x.
Yes.
So that's going to be the same thing as secant squared x.
Sine reciprocal is cosecant. Cosine reciprocal is secant. S to C, C to S. Okay, and tangent, cotangent are reciprocal to each other. Next. Let's try cotangent x derivative. Don't worry, right now if you feel this is easy, we will make the question hard very soon, okay? If you think it's hard, then this is the time for you to catch up. Eden, go ahead.
Okay, so cotangent can be rewritten as the derivative of cosine x over sine x. So if we were to use the quotient rule, then that would mean that, so we could rewrite it, so cosine x over sine x. So we could take the derivative of sine x, the regular sine x times the derivative of cosine x.
Okay.
Regular sine x times the derivative of cosine x. Yes, it could be written either way.
And then?
Minus cosine x times the derivative of sine x. And then
Divide
over sine squared x. So the derivative of cosine x is negative sine x, so it's negative sine x sine squared x, negative sine squared x, minus, since sine x derivative is cosine x, so minus cosine squared x, all over sine squared x.
Cos.
So it could be rewritten as like negative sine squared, negative 1, plus negative 1 minus,
Over.
Yeah.
Who is this?
Oh, that's negative cosecant x.
Good.
Yeah, negative cosecant x.
Very good. Very good. Very good. So students, you notice that if you miss just one AP level class, you feel like it's hard for you to understand. That's very true for high school 11th grade. Some students, they get sick for just 1 week and they totally messed up with their GPA for their ranking. 11th grade grading is the most important for your college application. Next, keep going, okay? Keep going. I need to ask Aaron. I want you to show me how do we do secant x derivative. Go ahead, please.
You can split it into 1 over cosine derivative, x derivative.
Sure. So you do 1 over cosine x. You want to use power rule, chain rule, or you want to use quotient rule?
I'd use the quotient rule.
Sure, let's do the quotient rule. Go ahead.
It's derivative of 1 times cosine x, and then
So 1 derivative times cosine x and then minus
1 times cosine derivative. The
1
derivative
times cosine x derivative over
cosine squared.
very good.
So
Who is this?
0.
Who is this? 0. Constant number is always derivative equals 0. You may wonder why. Because if you have a constant velocity, that means the acceleration is 0. Okay? Yeah, it's a constant velocity. You have a constant number, the slope of a horizontal line is 0. So this is always 0. So this is gone. And who is this?
Negative sine x.
So this is negative sine x. Now we can write down here. Who is this?
Tan x.
Hold on, we have something wrong here. Who is this?
Negative sine x.
Negative. So negative times negative is positive.
Yeah.
So this is positive. Who is this?
Tan x.
What's the next part?
Tan x times secant.
Good. Makes sense now? Now, I also want you to do the chain rule and the power rule. Let's go. I will rewrite this as this. Can you give a try, Aaron? You can do it.
Negative 1 times cosine x to the power of negative 2
Times.
times
Yeah, so the out layer, you apply the power rule. The inner layer, you will take care of this guy. Times who?
times negative sine x.
Good, which is cosine x derivative. Excellent. So this is negative 1 over cosine square x. Cosine x derivative is negative sine. So this gives you a sine x over
Cosine
cosine x and then cosine x. That's why you have tangent x times secant x. There you go. Make sense?
Yeah.
Okay. Next one. Cosecant x, Joyce. Let's do here, please.
Cosecant x is equal to 1 over sine x.
Next.
And then you do the derivative of 1 times sine x
minus
minus 1 times the derivative of sine x
divided by
sine squared x.
now who is this? Who is this?
That's 0.
Who is this?
That's cosine
So
x.
negative
So
cosine x divided by
sine squared x.
uh-huh.
And then
Now who is this?
negative cosecant. Oh, negative tan. Oh,
Negative
negative cotangent.
Negative cotangent x times cosecant x. Okay, makes sense now. All right. Now we need to introduce something more about this. And you say e to the power x. If you're confused, you say, I want to use the power rule. No, this is not the power rule. You do x to the power n. When x is on the base, you do this. That is called the power rule. But if your x is on the exponents, power rule doesn't apply. Power rule apply for this. Power rule doesn't apply for here. So how do you get this guy derivative? When there's no way we can go, we go to the original definition. This is the original definition. So you do e to the power of x plus h minus e to the power x, and then divide by h. You extract this one out, and you have here. Again, you say, how do I know this? Well, in limit calculation, there is a very important rule called L'Hospital rule, but we haven't learned that rule yet, so we are not able to apply that rule to calculate this. So far, what we do is by using graphing calculator to figure out this. So what you do here, you just go ahead e to the power x minus 1 divided by x. When x is 0, this results as a 1. So you are saying that is 1. So this result is this. So you might feel curious. How come you make this to be true? I still don't get it. Well, to truly understand this background story, you have to wait until you learn calculus BC to know the Maclaurin series, Taylor series, because later after you learn that, you will know e to the power of x is going to be able to be approached by this. Okay, you will learn this as the last chapter of Calculus BC, but AP will not follow, will not cover this because you have hundreds of pages not covered yet so that you are able to understand this part. But you can write down these notes. This might be help you for the second semester. And you may wonder, can I try look at this? Okay, so If I don't let you see these two edges, did you see these two curves are almost the same, right? These two curves are almost the same. So if you say, I want to increase this, you see, what will happen? I see that they are not exactly matching. What you can do? Easy. You can by adding another next term by putting x to the power of 5 divided by 5 factorial, which is 120. You see? You can keep adding. If you make your terms higher and higher all the way up to infinity, you will be exactly duplicate the curve of e to the power x. Depends on how many terms you want to put there. So 120 times 6 is going to be 720. And this top is x to the power of 6. Did you see? Is this a magic? No, this is not magic. It is just a Taylor series. Okay, this is just a Taylor series. See how beautiful it is. If I don't show you, you don't know that they are not the same function, but their curve looks like exactly the same. All right, if you continue learning with me, that's the same for BC part, okay? But just introduction. Now you need to remember, e to the power x derivative will be exactly e to the power of x. Now, this question is going to challenge your Algebra 2 foundation. I'm going to hold my answer here. I want to see if we have a super smart kid in this class to figure out this question. E to the power x derivative is going to be e to the power x. If you have a base which is not e, so you put a to the power x derivative. What's the result? Okay, I already showed you my answer just now. Okay, now go ahead, all of you, start using all your Algebra 2 foundations to figure out what's this. Give it a try. If you know the answer, you get the answer, you can text me privately, okay? Who figure it out? Anybody? Aiden, you know how to do this one? Aiden, do you know this question? How to do this one?
I believe my answer is probably wrong. So.
Let's give a try. Tell me what's your answer?
Was it anywhere close to a over x factorial?
No, the direction is not correct. The direction is not correct. I want you to manipulate. Look,
Do you use logs for it?
That's true. I don't know if any of you remember that you learned this thing long time ago. Does anybody remember this formula? Look, look. A to the power of x can be rewritten. Look at here. This guy can be rewritten as this. You know why? Look, log and exponentials are inverse function to each other. So when I write down this, I don't know if they are equal, but can you imagine ln of a to the power x equals ln a to the power x? Does everybody agree with this? This is true, right? Yeah, this both sides are same. True. This is base of e. So that means e to the power of this guy is equals to this guy. Okay? E to the power of this guy is this guy. Does this make sense? Ln of a to the power x equals to ln a to the power of x. So this is base of e. That means e to the power of this whole thing equals to this piece. E to the power of this whole thing equals to this piece. Just like what you say, 2 to the power 3 equals to 8. Log base 2 of 8 equals to 3. So 2 to the power 3 equals to 8. Base to the power this equals to that number. So e to the power this equals to this. Is this one clear for everyone? Now, that guy is who? You have logarithm properties. If you have somebody on your shoulder, you will pull this x in front. So this x will be able to pull in front here. Is this one okay? You have the log properties. Okay? X can be pulled in front. This is algebra 2. As I said many times, any single part for algebra 1, geometry, algebra 2, pre-calculus. In the past 4 years, any single small piece that you didn't build up your building very well is going to be able to collapse you coming to calculus. So when you have trouble here, you won't be able to do this. Now, Christina, this guy is here, right?
Right.
Now I'm going to replace here. That's okay?
Yeah.
Now, I have the e to the power x ready. So I'm going to copy down e to the power of this whole thing is e to the power of this whole thing. So just rewrite this. So far, so good?
Yeah.
Times. The problem for here is you cannot say this guy equals this guy. Look, here is x. That's okay, because x derivative is 1. But here is not x. So you have to do this guy derivative one more time.
The ln
Mm-hmm.
Oh.
Right. Now look at this. Who is this? It's this, right?
Yes.
So you will replace this guy by here. And then this guy, x times ln a, just like x times 3. Derivative will be 3. Okay?
Right.
So you copy down this. That's the formula. That's the formula. Everything I show you here for sure will happen in your school quiz or test and your college board AP test, for sure. Even though in the past 2 years, many good colleges, top colleges, they say test blended or test optional. But in the past 2 years, imagine so many students where their math background is horrible get accepted into those good colleges. And now the college knows that how bad or how dangerous this will be. Even though they get into those good programs, they won't be able to pass the test. They won't be able to graduate. Okay? Math science is not like you just brag yourself, you see, you just brag, you just say something crazy. No, math and science need those foundations. Nobody can lie over there. That's this formula. Any question? Any question? After I go through all these formulas, we will go to the tough part for today's topic. Y'all should be ready when you do something hard. Next, we will do the ln x. Ln x. You want to do this guy derivative. I say, oh my gosh, we need to do that guy derivative. This is crazy. I'm going to show you how we do that. Y equals to ln x. Y equals to ln x. So, Lily, ln x is log ex. Okay, so far so good?
Yes.
Can you rewrite this equation so that we can treat this equation as an exponential equation? E to the power of who equals to who?
E to the natural log of x equals
E to the power of y equals to x. Correct?
yeah.
And then we are going to use the derivative. We will do the derivative for both sides. Okay? Watch out here. Is this okay?
Yes.
And then we are going to do this guy derivative. We just learned this guy derivative is who?
E to the x.
E to the power x. But when you use the formula, x is x. Here the y is not x. So you have to do the chain rule one more time. E to the power y derivative is e to the power y. And then you will do the y derivative, which you just write down here. Make sense?
Yes.
X derivative is who?
1.
1. So y prime equals to 1 over e to the power y, which is 1 over x. Make sense?
Yes.
The way we do here is called implicit. Implicitly, okay? You might want to write down this. This is something important. Implicit way. Okay. So far, so good. Everybody okay so far? Now, if nobody say you have question, I'm going to ask y'all those formulas are important formulas. Aiden. Who is this? Look at the camera. Don't look at your notes. This guy derivative is who? Aiden? What's this guy derivative, Aiden? Huh? How much? What's the answer?
1 over a.
What? No, look at your notes. Read the answer from your notes. Go. What's your answer? What's the answer? You copied down just now? Really? I thought just now when we go through, I ask you, nobody have question. Simple one, you don't know what's the answer. You don't know that answer? Here, I show you. I show all of you again, okay? One more time. This guy derivative equals this. And then ln x derivative equals to 1 over x. Now, everybody, go ahead. Write down on your paper. Don't copy. Do your own. And send me your answer. Start now. Do it. This is based on e to the power x. Derivative is e to the power x. Go ahead, y'all do this and send me messages. If you don't know how to do, if you don't know my number, here is the number. You can text me only during the class time. Go ahead. You do this, screenshot your work, send me, text me. Do it now. How you get here? Copy down doesn't count. Aaron, you, I don't see the way that when I show you, explain to you just now. How do you get this guy derivative? By the way, you put this as ln x. The answer is wrong. That's not right. Aaron, the answer for this, you didn't get correct. Who else? Who else? Do you guys know how hard it is to be accepted by UT Austin? If you are a student in Clemens, do you know how hard, how tough? 11th grade, you need to take 7 APs. And for each AP, you need to reach to the grade above 96. Okay, it's so that hard. It's so that tough, extremely hard. Next May, very possibly many of you will take all the 7 AP tests, College Board test. Imagine that week, some of you may take 8 hours test a day. That's horrible. Yeah, I have Christina good, Judy good. Aiden, where is your work? Aiden. Ryan, that's right. Aiden, where is your work? I'm waiting for your work.
It's sending.
Okay. Aiden, why you have a e to the power a ln of a to the power x equal e over x? That doesn't sound right. The last step, that's not right. That's not right. That's not right, okay? Now, I will upload the notes. Everybody, make sure you truly understand everything on this. I summarize all the important formulas in this so that you go through everything. We have to start the implicit way today anyway, okay? Now, let's see here. Look at this. They ask you to get the derivative of dy over dx. And you might wonder, how about I make y squared equals to 36 minus x squared, and then y equals to 1/2, this guy to the power 1/2. And then I use a power rule, and then I use a chain rule. Yeah, we can try that way. And we can compare that the implicit way work gives you the same result as this way. But sometimes this is possible. This is possible to convert into a function of y. This too is possible if you use a traditional way. It is still possible. But look at this. How are you able to solve your y? Are you able to solve your y? Some students say, hey, easy, minus y times x minus y equals to 4. Then y times this is going to be x cubed minus 4, and then y equals this thing divided by this. Come on. You cannot have a y over here. That's not a function. you can only use x on one side to represent your y. This one is non-solvable. You won't be able to get your y value. Not all the equations can be converted into the explicit way of a function. I say this one more time. Not all the equations can be converted to the explicit function for y. Like this, you won't be able to solve your y at all, but you are able to solve your y prime. Interesting. You are able to solve your y prime, but you were not able to solve your y. And you might wonder, what crazy is this one? You won't be able to draw this graph easily. This part can only be drawn by using graphing calculator.
I'm sorry, but is the derivative of dy over dx the derivative of y?
Which one you're talking about?
Like, are we looking for the derivative of y here for like
Yes. We are looking for derivative of y.
Okay.
I'm showing you guys here. You might wonder, what's this? What does this represent? You see, it's a curve like that. You want be able to figure out the y equals to, like, for example, you have this equation. You want to rewrite this as, so for example, y equals to square root of x minus 1 squared plus 2, and do a vertical compression and do the vertical shift. You won't be able to solve this one at all. So the old traditional way to figure out the y is not working. You cannot do your y, then you won't be able to use the old way to get the y prime. What do you do? Implicit method.
Can we not find it because of the xy?
Yes, because that guy, because this guy. That's true. This is true. I don't know any of you still remember in pre-cal. Look at this. In pre-cal, we learned this kind of thing, right? Rose petals. Who else? We also learned spirals, okay? And we also learned limicons, okay? That's what we learned in pre-cal. But a simple equation, a very simple equation in the polar system with the theta and the r, it's going to be a crazy equation in the xy coordinates. So you won't be able to figure out your y at all because there are some crazy terms. Sometimes they even put this. So in this way, when we solve the derivative, we will not use the traditional way. We have to use a way called implicit. So let me show you first example. You have here, so you move the x squared to the right, you have this. And you may say, I think you have to put plus or minus over here. That's true because you don't know your y is positive or not. But let's first suppose it's positive first. And then when we come here, let me call student, okay? Judy, let's do this guy derivative using the power rule. Go ahead, please.
So that'll be 1/2 parentheses 36 minus x squared to the power of negative 1/2 times the derivative of 36 minus x squared, which would be 2x.
Negative 2.
I'm negative 2x, sorry.
Okay.
Negative 2x. So then it would just be x times 36 minus x squared.
This is negative.
Negative
And
x.
this is 36 minus. So let me put this in the denominator. You have a square root on the bottom. You have an x on the top. Okay? Makes sense? Yeah. And again, you have a y square here, right? You have y square equals this. You see? So
Yeah.
you can replace this by y square, right?
Yeah.
So you replace this by y square. Okay?
Yeah.
Now, because we choose here to be positive, so when we square root y square, if y is positive, it's going to be y. So this equals to negative x over y. Make sense?
Yeah.
But if at the beginning you choose a negative here, then when you have a negative number square, you will choose another negative, which will come in the same result. Okay. And if you feel that part confused, don't worry. You just do this. It's good enough. Good enough. Now, this is using the traditional way. Now, let's do the new way. Let's get the derivative of each term, please. This guy derivative will be.
Oh, am I still doing this? Oh, okay. So that'd be 2x plus 2y equals 36.
Hey, be careful. Oh, be careful. Because y is not x. You cannot just.
Oh, yeah.
Yeah. Okay. Y is special.
Okay.
Plus.
Would that be the derivative of, are we still like, are you going to sub in 36 minus?
2 times y prime. That's what you are doing.
Oh, okay. I get it now.
Outer layer, the
Yeah.
outer layer is this. Inner layer is y, so y derivative. Okay?
Okay. Yeah.
The reason here, because x derivative is 1, so you just write down here.
Yeah.
But this one, y is a y, so you have y prime.
Okay.
Equals to 0.
And
then y times y prime equals to negative x, right?
Yeah.
So y prime equals.
Y prime equals negative x over y.
That's it.
Okay.
Yes. Compare. Which way you like?
The second way.
Yeah, you can do this so quickly, right? Okay. Now, we will forget about the traditional way. We will just go ahead and use a new way, okay?
Okay.
Yeah. So let's see here. I don't know if any of the boys like playing video games. If you play a very hard video games and when you have your friend who is so super good on that tough games, and when that guy sit by you, you feel way more better because anyway you can do it because somebody is helping you. Okay, I'm pretending to be that guy who can play that game very well. So I will go through this with you, and you don't be panic. Right. Let's go here.
Okay, so 3x squared.
Yes.
Let's see what that would be.
Minus. We will use the product rule.
Product rule.
This
that would be y. That would x's derivative is 1.
Yes. Copy down the y.
Y plus x times y plus x times the derivative of y.
Good.
And
Very
then
good.
plus 2y times derivative of y
Excellent.
is equal to 0.
Yes. Good. Next step.
And then you would go 3x squared minus x
Minus y.
minus y, and then minus x times y prime plus 2y times y prime.
Next.
Um,
Let's moving these two guys around to the right, please.
so 3x squared minus y is equal to x times y prime minus 2y times y prime.
Good. Continue.
And then
This is x minus 2y times y prime, right?
yeah.
You
And
are
then
almost very close.
3x squared minus y.
Go ahead.
And then we see would you
This-
want to
You do this.
y prime is
divided,
equal to 3x squared minus y over x minus 2y.
Excellent. That's it. How do you feel?
Great.
You accomplish this. Okay. Very
Yeah.
good. Very interesting. You won't be able to solve the y, but you will be able to solve the y prime. Okay. Yeah. Look at this one. This one, you won't be able to solve your y either. This one. This is cube. This is 1. You cannot solve your y. So we cannot use a traditional way. We have to use a new way. Lily, let's try number 4. Go ahead.
X cubed times.
You want to do this guy derivative first, right? You treat this as this two product. So you do this guy derivative, copy down this one, plus this one, copy down, times this guy derivative, okay? You got it?
Sorry, can you repeat that again?
So I'm going to write down here. You will do this guy derivative, copy down this one, plus this one, copy down this guy derivative, okay?
Okay.
Didn't I just review this with you today? You got it? Lily? You have here, right?
Yes.
Yeah. I'm sure you can follow through. Just because you missed one class, that's why this part is a problem for you now, right?
Yeah.
So look, if you are going to be 11th grade or you are going to be 12th grade, this is the most important 2 years among your whole life. Make sure ask your parents give you very good food for these 2 years every day, and you have good sleeping habit. Make your health healthy so you can handle those things. You cannot afford a sick week. That's going to be dangerous, really dangerous. You think AP physics, AP calculus, AP chemistry, AP biology, AP psychology, AP English. an AP another class. Miss 1 week. Imagine how much work you need to do the makeup. Okay. Now go ahead. Lily, continue. This guy derivative is who?
So 1 times 1.
1 times y plus
Plus
x copy down times y derivative. Okay. Yeah. I once have a student during her 11th grade. She did just a small surgery, so she missed school for 1 week. When she go back to school, she have to take a huge trunk for the international traveling. That kind of big size luggage to take her 1 week of schoolwork back home. Can you imagine? Continue. This is who? Did it continue? This one is who?
Is it?
This is 3 times x squared times y cubed. Okay. And then plus x cubed times this guy derivative. This guy derivative power rule first. So 3 times y squared. Y is y, not x, so you do y prime. You got it?
Yes.
Okay. And then minus y, and then minus x times y prime. So far, so good?
Yes.
And then you will get here and here, and you will moving this around. You can do this part. This is order 1 part. Go.
8 squared times y cubed equals 1 minus x cubed times 3y squared times.
Okay. So you have x cubed, 3x cubed times y squared minus x. Did you see here? Is this okay? Lily, is this okay? Yes or no?
Yes.
Equals. You move this other things around to the other side. Okay? So this is 1 minus 3x squared times 1 cube, and then plus y. Does this make sense?
Yes.
So y prime equals 1 minus this over this. Now so far good?
Yes.
Okay. Oh, you see those questions. None of them is not ugly. All of them are very ugly. Now trigonometry kick in. Joyce, let's do number 6, please. Go ahead.
You find the derivative of sine x,
Which is?
cosine x.
And then plus.
And then plus the derivative of that.
2 times who? This guy derivative is who? Cosine derivative is who?
Negative sign.
Good. You write down negative sign. You copy whatever inside. And then you need 2 times who? I'm waiting for this piece here.
Y derivative.
Very close. And you miss a number in front, which is?
2.
Yes, because it's not y. If this is y, you do y prime. This is 2y, so you do 2 times y prime. You got it? Make sense now? Yeah, now next step is easy, right? So this is cosine x minus 4 times. Yes. So y prime equals?
Cosine x over 4 sine 2y.
You got it now? Okay, that's it. Oh. Christina, let's try number 7. First, I will rewrite this as this. Now let's do the derivative for each of them. Go ahead.
Okay. The derivative of sine x is cosine x,
Because
and that equals 1 plus the derivative of x, which is
1 times
times
tangent y.
Tangent y, and then plus the derivative, which is secant squared x.
You copy down
secant
x.
squared y.
Yeah, you copy down
times secant squared y.
And then
times the y derivative.
That's it. Excellent. Everybody, any questions so far? No? Everybody do this question by yourself. Some parents told me that some kids in the summer, they just want to enjoy their summer before 11th grade. Okay. And then when school start, they have the peer pressure to take the same high level AP course like other friends. But the problem is none of the AP class will be easy, especially for these 3 classes, AP Calculus, AP Chemistry, AP Physics. So if you don't get ready during the time you take it in school, each class, parents feel like their kids is going to the funeral, not going to the class because they cry, they feel sad, they feel depressed. Anybody finished? If you finish, you text me. Eden, you finished? Very good, Judy. Who else? Okay, right, finished. Christina. Okay. Aiden. Okay, that's pretty good. So even though at the beginning you feel this kind of way is hard, but actually after you do it, it is not hard. Okay, yeah. You're just moving around and you do the derivative for both sides, and then you're moving around, you will be able to get your y prime. Everybody else is on the other side. Now, try number 8 also. This one, you want to pay attention. You want to know who is the outlier. So the outlier here is the sine. Sine derivative is cosine. So you have this guy outside first. Okay, this guy derivative is cosine. And then you will times this guy derivative. X derivative is 1 times y plus x copy down times y prime. And then you will be able to solve your y prime. Everybody go ahead to number 8. Anybody finish this one? After you finish this one, after everybody finish this one, we take a 2 minutes break and we will be back, okay? Do this, text me, and then you can take your break. Anybody need help for this question? Let me know. Don't feel shy. Y prime equals to cosine. This copy down. Then x derivative is 1 times y plus x copy down, y derivative. And then distributive property, and you solve your y prime. Yeah, very good, Christina. You can stretch yourself, okay? Anybody else who finished this one? After I told you the result, the next step is just algebra 1. Okay, solve the later equation. Aiden, y prime, you cannot make this equal 0. If this is the number 4, then this guy derivative is 0. Here is y. Y prime couldn't make it equal 0. That's not true. Aiden, you see what I mean? Aiden, double check your work. This one derivative is this one copied down. This one derivative is not equal 0. Nobody say this. That's wrong. Okay? Redo your work, Aiden. Anybody finish this? Aiden, you understand what I'm talking? Answer me.
Sorry, I had to find something.
Can you redo it?
The problem.
Yeah, y prime, you
Yeah.
cannot put a 0. Oh, that's not correct.
Okay.
Yay, Judy, that's right. All right.
What were we supposed to do with the y primes on both?
Huh? Judy, you want to be careful. There is some typo here. What's your question? This guy
What were you
derivative.
supposed
Say one more time, please.
what were you supposed to do with the y primes on the two different sides?
You leave it. You leave this as it is, and you wait for here to be finished. X derivative is 1 times y plus x copy down times y derivative. And then you do this distribution. You do this distribution. Okay? And then this term move to the left. You have
Just
this term.
subtract.
And then you do this whole thing, divide by this whole thing. Judy, you miss a 1 here. Judy, you miss this one, okay? All right, 2 minutes break. We will be right back, okay? Everybody back? Okay. William, unmute yourself. Let's try one question, okay? It's okay. Yeah, you missed many classes, so it's okay. Let's try this one here. Let's do this, okay? Suppose you are playing a game that you never played before, okay? I'm going to guide you each step so that you can play by yourself. This guy derivative should be what? This is the formula. So you will put 2 in front and then times x to the power who?
2 times x to the power of 1.
That's good. And then you minus y cube. Y cube derivative will be who?
3y to the power of 2.
Very good. This is excellent. Times. The thing here, you can do 1. The thing here is y. Y is a function of x. So you have to do one more step called y prime. Does this make sense to you?
Okay.
Okay, show your face. Show your face. Don't feel shy, okay? Yeah. And then you will move around. So 2x equals to 3y squared times y prime. So y prime equals to who? Go ahead. Y prime equals who? This divided by this, right?
Yeah, y prime equals 2x divided by 3 times y squared.
That's right. And they ask you, find the derivative at the given point. They give you the point x equals to 1. So we are supposed to plug in x equals 1 into this equation. So 1 squared minus y cubed equals 0. So y equals how much?
Y equals 0.
Hey, hold on.
Wait, no. Y.
1 minus y cubed equals 0. So y cubed equals 1. Y equals?
Yeah, y cubed equals 1.
Y cubed equals 1, so y is 1, right?
Yeah.
Now, you have your x, you have your y. You feel welcome to plug in. 2 times who?
2 times 1 over 3 times 1 squared.
Which is?
Which is 2 over 3.
It's my class rule. You show your face in front of the camera, okay? Everybody is doing the same way. Everybody. Show me your face. Show me your face. Yes, I need to have contact so that I'm able to know you understand or not. Show me your face. Show me your face, please. So that when you knock your head, I know that you truly understand. I need some eye contact. Even in the online class, I still want to make my class as good as possible, okay? Now, look at this. Your derivative is 2 over 3. So this is something very cool. X squared minus y cubed. X squared minus y cubed equals to 0. So this is a curve like this. This is saying that when your x is 1, so you put 1, 1. This is the point. In this way, you don't need to worry about finding a tangent line at this point and figure out the slope. You will be able to figure out the slope by doing this, okay? And then if you use a point slope format, let's refresh some algebra 1 foundations. If you have an x0, y0, if you have a slope of k, what is that line function? Do you remember?
It's like y minus y1 equals m parentheses x minus x1 times k.
Yes, yes. Now, we have the point 1, 1. We have the slope of 2, 3. So we can have that tangent line equation. Make sense?
Yeah.
See? So if we want to double check if our calculation here is correct, we can type in this y minus 1 equals to 2 over 3 times x minus 1. Look at this. Isn't this a perfect tangent line and exactly tangent point at 1, 1? Yes?
Yeah.
You see, if we put the wrong number, that's impossible, right? That's wrong. That means our calculation is perfect here, okay? So far, so good?
Yes.
Next, look up. Very soon, we will be able to feel how powerful calculus is very soon, because we will learn the relative rates question and the optimization question. Because as what we learned in the first class, we used to just depending on the graphing calculator to figure out the mean and max. But after we learn calculus, we will be able to find those critical points by doing the derivative. Number 11. Joyce, do the derivative for each term, please.
2/3 x,
Mm-hmm.
and then to the power of negative 1/3.
Plus
2/3 y to the power of negative 1/3.
times this is y. This is x. X derivative is 1. So you copy down y prime, right? Equals who?
5.
5 is a constant. This guy derivative is 0.
Oh.
Make sense? Now we will move this guy to this side. Let's do it. So far, so good. Make sense?
Yes.
Okay. 2/3 can cancel. They can be gone. So y prime equals
x to the negative. Oh,
that's right. That's right. X to the power of negative 1/3 and then times
y to the 1/3.
That's it. Now we want to plug in. You have 8, 1. Go ahead. Y prime equals to x is 8 and then y is 1. Joyce, how much is here? How much?
1/2.
1/2.
Excuse me.
Mm-hmm.
When you move the 2/3 x times negative 1/3, so like the second line.
Oh, have negative.
Yeah.
Yeah, good catching. Yes. Good catching. Thank you. Thank you. Very good. I really appreciate this kind of help. Okay, very good. This is negative 1/2. Okay, makes sense now. Joyce, this one okay?
Yes.
Now, let's do here. Christina, let's do this one.
The derivative of x cosine y is 1 times cosine y plus a negative sine y times y derivative times x, and then that equals 0.
Yes. And
then it's cosine y minus sine y times y derivative times x equals.
Yeah, you just move this to one side, okay?
Yeah. Yes.
Then y prime equals?
Y prime equals cosine y over x sine y.
Cosine y over sine y is who?
It's square root of 3 over.
This is cotangent to y, right?
Oh, yes.
Then we can plug in.
Over. Yeah.
But we need to figure out the x. So cosine pi over 3 is how much?
Square root of 3 over 2.
No.
Wait.
Who is this?
Oh, 1/2.
1/2. So x equals
2. Yes.
correct. X equals
Yes.
2. So x equals 2. Then this is cotangent y. Cotangent pi over 3 is how much? This is same as tangent 1 over tangent pi over 3, right?
Yeah.
So how much? What is this?
That would be square root of 3.
No. Tangent pi over 3 is square root 3.
So it's 1 over square.
Yes, so this is 1 over 2 times square root 3.
Square root 3.
And then you do this. So far, so good?
Yeah.
Right. Look how this is just the AB part. Second semester is really crazy. Number 13. Ryan, try this one. Go ahead.
I don't remember the identity to separate out the 10xy. Do we need to do that?
We do the chain rule. You use this formula first. You know this formula, I know. Who is this? Who is this? Hey, we did this today just now. Go to your notes.
Yeah, I remember. I'm just looking right now. Secant squared x?
Secant square. So you do secant square and you copy down this whole package, okay? So far, so good? Times who?
Y prime. Not y prime. X plus y.
Derivative, right?
Prime. Yeah.
Yeah, x plus y. Derivative is who? It's equals to this guy derivative plus this guy derivative. Who is this guy?
1 plus 1
yes.
y prime.
Yes. Equals?
Secant squared x plus y.
Hold on. This guy derivative is who?
That guy derivative was 1.
1. So 1 plus y prime equals to 1 divided by?
Secant squared x plus 1.
Yes.
And then minus 1 to the other side.
Tell me, who is this? Who is this?
Is this an identity or?
Yeah.
Yeah.
Cosine and the secant are reciprocal, right?
Oh, well, that's
C
it.
to
Okay,
S,
so
S to C, right?
cosine squared
Mm.
x plus y, and then I did not remember what that like came out to when the x plus y the function was.
Like this, okay?
Okay, that's
yeah. And then let's plug in. Go ahead.
0 plus 0. So,
X. So y prime equals to cosine square 0 plus 0, which is 0. So
yeah.
how much is cosine 0? Don't rush.
Cosine at 0 is 1.
Yes, 1 minus 1 is
0.
0. You may feel curious, what kind of curve is this one? Okay, we won't be able to solve this by hand. So we have to type in this. You'll have this, okay? So at 0, 0, it's a flat one. That's why the slope there is 1. It's 0, okay? It's flat, right? You got it?
Yep.
That's what this one is. Oh, this is crazy, right? All right. You might notice that question. Some question.
Wait, can you go back to that question
Sure.
one
Sure.
for a second?
Okay. Yeah.
Okay, I'm done. Thank you.
Any other question here for this page? We are going to do another one. Implicit. This here. So at the beginning, those questions easy. X squared derivative 2x. Negative 5x derivative is minus 5. Okay, that's easy. And then for here, you will put 1/2 in front. You put negative 1/2 because 1/2 minus 1 is negative 1/2. And then times 2x. And then 2 canceled, you got here. That's all easy. And then we have to deal with this kind of questions. Let's try here. Williams, let's try C. Let's try C. It's going to use the product rule. You split this from here. So basically, look at here. Can you unmute yourself, please?
I'm muted.
Okay. So you will do this piece derivative times this guy plus this guy times this guy derivative. So you will just first copy down this guy derivative times who? Okay.
Times sine.
Times sine y. Very good.
Yeah, times sine y.
Very good. Plus who?
Plus derivative sine times cosine x.
Okay. Very good. Very good. Equals?
Equals square root of 4.
This guy derivative. No matter how big this number or how ugly this number here, you can just say this all equals to 0 as a constant. Constant line slope is 0. That's why you just write there. So far, so good. Yes. Now, based on the notes just now, can you find out the answer for here? Cosine x derivative is who?
Is that just like 1 over secant?
No, I'm not asking for the identity. I am not asking the identity. By the way, your identity is correct, but I'm asking for the derivative. So if you see, students, when you don't know the answer, you can quickly go through our folders because all the notes is exactly ordered in the organized way. Every homework and the notes show you all the work. So you can
Where do
see.
you find the notes?
Huh? Where did you find them? Really? It's in the folder. All of you look. Now verify this right now for me. Are you sure you are not listed here? Who's asked me? Ryan, you asked me?
No, that was me. Oh, William.
You are here?
Yeah. I'm in the other one.
Okay. I send you all the link, and your mom, some of the mom also have the link. So that means you have the folder. You receive one-time email saying that here is the link, and then you open that.
Oh, I found it. I found it.
By the way, if you have a Google Drive downloaded in your computer, you just click the shared. You will be able to look at the folder that I shared to you. All right. Now, you see here, constant C derivative will be 0 always. And you see the sine derivative is cosine. Cosine derivative is negative sine. So use the right table. Can you please finish this?
So it'll be negative sine times sine.
Negative sine x times sine y. You have to say x and y because sine doesn't mean correct. Okay, you have to put the x, y in the correct spot.
Plus cosine x times cosine y.
Y times
d over dx.
Y prime, dy over dx is y prime.
Y
okay. Tell you some small story, interesting story. At the beginning of calculus, there are two famous person. So the first guy is called Newton. He designed this symbol, y prime, and he used the y prime as delta y over delta x. And he want to make the delta y approach to very, very small value like zeros. In that way, he introduced the limit saying when your delta x approach to 0, and then the dy over dx, delta y over delta x, this is going to be dy over dx. And he called this guy as x prime. And he designed it this way. Okay, this is what Newton designed. And there's another famous person called Leibniz. He introduced this symbol. And these two persons fight for who is the first person to introduce calculus. They fight this. And their grandchildren still fight for this. That's interesting. Okay. And later on, when we learn about the L'Hospital rule for doing those derivatives, I will teach all you guys another very interesting story. Very interesting story, okay? Especially important for boys. So I'm going to leave that later to introduce that interesting story to you. Now let's continue. Go ahead. You can move this to the other side, right? Correct?
Yeah.
So cosine x, cosine y times y prime equals who?
Equals sine x times sine y.
So y prime equals?
Y prime equals 1.
No, these are not the same. You cannot cancel, right?
Oh, wait,
so
so
sine x?
So sine x times sine y over cosine x times cosine y.
Yeah, that's right. Now, who is this?
That's tangent.
Yes. So y prime equals?
Tangent squared x?
No, tangent x times tangent y.
X. Tangent y.
I didn't say this is tangent x. You cannot say tangent square x. No, y and x are different. Okay? Make sense now?
Yes.
Next one. You have a x squared plus y squared equals to 25. Look at this. Hold on. Yeah, hold on. Let me talk about this one. This one here. The question is over here. They ask you to find the tangent line to this equation at the point of this. If you are students in 4-band SD, I believe you have this in pre-cal before. I say, teacher, you can draw so perfect. Not because me, just because it's apps. And then you have phi and negative phi. And you have a point -3, 4. And you are looking for the tangent line. You are looking for the tangent line. Like that. Okay? Now look at this. They ask you this line equation. They ask you this line equation. You want to get this line equation, you might notice that since this circle is centered at 0, if you connect between the tangent point and the center, this is a radius. The radius is always perpendicular to the tangent line. So I am able to writing down here -3, 4, 0. The green line. Who can tell me the green line slope is? Who know the answer? Just say it. Who divided by who? You pass this point, you pass 0, 0. Come on. Slope formula. Everybody knows this. -4 over
4.
-4 over 3.
4.
4 minus 0 divided by -3 minus 0, which is this, right? Yes. Now, this purple line slope will be how much? Who knows the answer? Just say it.
3/4. Yeah.
3 over 4, because they are negative reciprocal. Now, you have the point, you have the slope. Y minus 4 equals to 3 over 4 times x plus 3. You got it? Make sense here? Now, this is based on our geometry and algebra 1 knowledge. And here, this one, we can use the derivative. X squared derivative is 2x. This derivative is 2y times, you can do dy over dx. This is called the Leibniz way. You can do y prime. This is Newton way. Both ways are correct. And then you have this point, -3, 4. So -3 plug in, -6 plus 8 you have here. And then your dy over dx will be 6 over 8. So your slope is 3 over 4. And you may wonder, hey, this way is so simple. Why do I need to bother to do this way? Look, this is easy because it's a circle and it's centered at 0, 0. I can immediately change this to a very hard question. Say, I change this to an ellipse. I change this to a hyperbola. Then you won't be able to solve it without calculus. You know, I can say x minus 3 squared over 4 plus y minus 1 squared over 9 equals to 1. This is a ellipse, vertical direction, centered at 3, 1. And then I find the point and then say, go ahead, find the tangent line equation for me. Are you able to solve it in this simple way? No. You have to solve by calculus. Okay? So calculus solved millions of engineering questions. Okay? Without calculus, Tesla is impossible. Okay? This is another very hard example. I will leave this one until next class. Okay? All right? That's for today's class. See you next week.